recording. All right. Okay, so what's our skills here? We have some skills. Remember that? It's all about skills. What's our skills? We should be able to predict charges. Okay, and we should be able to write ionic compounds so far. And we should be able to name them as well. Well, ionic compounds. Now, this is what we got so far.
Can you share your screen, Mr. Pierce?
Oh, shoot. Thank you for telling me that, because I will forget if you don't tell me. All right, so we are going to share my screen. Thank you for not letting me go for like 20 minutes and everybody's going like, what in the world's he pointing at? Okay, so we should be able to see the screen now. Can we wait a minute. Do I have the screen? Hold on. Let me make sure that I'm sharing. Return to meeting. Share content, share. All right, now it says I'm sharing. Okay, now we're sharing. Thank you. That's so, but it happens. Technology, what are you going to do? All right, so we should be able to right now, we should be able to predict the charges, we should be able to write ionic compounds, and we should be name some ionic compounds. Now, the next thing we need to do, and I'm going to go ahead and pull up a periodic table here just to show you what I'm talking about here. Okay, so let's see, periodic table. All right, and let's get a periodic table going here. And there it is. Okay, so we got a periodic table. And if you remember, we were able to say +1, +2, +3, +-4, -3, -2, -1, and 0. Okay, we're able to say that. But what about all these guys in the middle? Like iron and cobalt and nickel and copper and all those guys. Well, we didn't mention those because they can have more than one charge. They can have more than one charge. Like, for instance, lithium, sodium, potassium, all in group 1, the first column, they're always +1. Your beryllium, magnesium, calcium, they're always +2. And like boron, aluminum, gallium over in group 13, they're always +3 and so forth, right? But you get in the middle and they can be more than one charge. So whatever are we going to do about that? Well, here's what we're going to do. Okay, so many elements have multiple charges. Okay, and somebody's waiting in the lobby. Hold on just a second if I can get to them. All right, stop sharing. Hold on just a second. Let me let her in. 2 participants are waiting. There we go. They're in. All right, now I'm going to go back to sharing. Share content, screen. All right, so many elements have more than one charge, okay? For instance, iron. We got another one waiting in the lobby. Hold on just a second. I don't know how to do this without stopping sharing. So let's see. There we go. Admit. All right. All right. Anybody else waiting in the lobby? You're on. Yeah, I know I'm not screen sharing right now. I'm just letting them in. All right. Share content. Share content. All right. Can everybody see the many elements have more than one charge?
Yep.
Okay, I'm sharing. Okay, so iron can be 2+. Iron can also be 3+. And copper can be just +1. And we got another one. Hold on. Everybody try to be back on time. I'm just saying. Okay, try to be back on time because I have to stop what I'm doing if I have to let you in. Share content. Okay, we're back. Everybody see my screen? All right, so copper plus, copper 2+. Those are 2 of our most famous ones there. Matter of fact, I think there's a way I can, bear with me ladies just for a second. Okay, let's see, participant, and I'm going to meeting, and I'm going to unlock the meeting. There we go. That'll cure that. Share, share. There it goes. All right. So we have more than one possible charge. So whatever are we to do? Because if we were to say iron plus oxygen, well, now you have two choices. You have iron with the 2 plus, and you end up with FeO, and you can end up with both of these situations here where iron with oxygen gives you that one, iron 2 plus, and iron 3 plus gives you that one. Same thing here. We could say copper with oxygen, and we'd end up with the same situation. We'd be Cu2O, and we would have CuO. Okay, and if we were just to name them like we have been naming, we would say, for instance, here we would say iron oxide, and we would say over here we would say iron oxide as well. But these are two different compounds. These are two totally different compounds. And so how do we tell them apart? And the way we're going to do this is we're going to focus in on the charge. We're going to focus in on the charge. Now the charge, we're using to cross the charges if we had to, right? We would use the charges to cross the charges, but we have a situation here. So what we're going to say is we're going to say this is not just iron oxide. We're going to take that 2 and we're going to call it Roman numeral 2 oxide. So this 2 is going to become a Roman numeral 2. And we're going to call this over here with the 3 plus, we're going to call this iron Roman numeral 3 oxide. And so the 3 is going to come on down. Now notice the Roman numeral only means charge on metal. It only means the charge on the metal. And I say that because, yeah, you're going to cross that 3 over. You are going to use that 3 to get the 3 on the oxygen. But look over here. You have a 2 and a 2. You have a 2 on the oxygen. And there's no 2 over here anymore. See? There's no 2. It's just the charge on the iron. That's what that Roman numeral means, because if you don't have the Roman numeral and you say iron oxide, I will say, well, which one do you mean? Which one do you mean? You say iron oxide. This iron oxide over here is a dark green. This one over here is rust colored. Because guess what iron 3 oxide is? Iron 3 oxide is rust. And so yeah, it's going to be rust colored. And so they're completely different compounds. Now, what would we call these? Anybody take a guess? We'll call that one number 1, and we'll call this one number 2. What do you think number 1 should be called?
Copper.
Yes, it's got copper. Yeah, copper. What do you think? Green number 1. Any ideas? There's 20 of you in here. I'm sure one of you's got an idea. You could be wrong. I mean, it's okay if you're wrong. I won't laugh at you too hard. Well, how about, let's say, when we're going to do it just like we do them all, we'll say copper oxide, right? But since there's more than one charge, we have to specify what's the charge. What's the charge over here?
1.
It's 1. Copper Roman numeral 1 oxide. There it is. And see, what's the charge over here? How about green number 2? Now, all right, here you go. Go ahead and tell me. Green number 2. What do you think? What would you name that? The green number 2.
Copper numeral 2 oxide.
There you go. Copper Roman numeral 2 oxide. Don't overcomplicate these things is what as what something I say a lot. But copper Roman numeral 2 oxide. Why is it Roman numeral 2? Because you got a 2 for a plus 2. Okay? Now, whatever you do, once again, don't ever say like dyes and tries. Don't call this dicopper oxide. Okay, don't do that. See what I'm saying? Don't do that. Or don't call that copper. I mean, just don't do it. Just don't do it. Don't say dyes and tries or whatever. It's just the Roman numeral you use for just if you have more than one charge possible. And generally, most of your elements, your metals that are in the middle of the periodic chart, most of them are going to have more than one charge. So you have to specify Roman numerals. Okay, so here's one for all the marbles. All the marbles. Let's see if we can do this one now. So I'm going to write up a compound here, and you tell me what this is. You should have a periodic table handy. That's a CR. And here is a 6 there. What do you got there? What do you think that would be called?
Chromium chloride.
Chromium chloride. That's what I heard. Problem is where is chromium on the periodic table? It's like over here, isn't it? Right? That's one of those that's going to require more than one charge, and chromium's one of them. So what would you call this? You would start with chromium chloride. Yes, you would. But it's going to need a Roman numeral. It's going to need a Roman numeral. And so how do we figure out what this Roman numeral is? Well, let's see. Chloride is what? Cl minus, right? So there's 6 of them. That's minus 6. What does the total charge have to equal? 0. What does this have to be right over here? What does the charge have to be on that chromium to get it to add up to 0? It would have to be
6.
6. It sure would, because 6 minus 6 gives me 0. So this would actually have to be a chromium 6, wouldn't it? So this would be chromium Roman numeral 6 chloride. Chromium 6 chloride. All right. Now you take a look at something like this, and that's aluminum oxide, but it has no Roman numeral. Why? Because it's always plus 3. Okay? It's always plus 3, so it's just aluminum oxide. Okay? Chromium chloride, because chromium's out over in here in your periodic table, is going to have more than one possible charge. Matter of fact, chromium, it goes plus 2, plus 3, plus 6. It has 3 or 4 possible charges. And you just look them up. You just look them up as far as the charges go. Okay? So that would be chromium 6 chloride. So if you had a choice, let's say that you were asked, what's the name for this? And you write down, I got this, and you say iron oxide, that's wrong. Why is it wrong? Because if you say iron oxide, I will say which one. Now, just like you got these numbers by crossing them, you can also uncross. You can uncross to get to the plus 3. You can uncross to get to the minus 2, you see? If the numbers are different, you're going to uncross. So what is this? This is Roman numeral 3. There it is. Roman numeral 3 oxide. You see that? Yeah. And so if we have, say, polyatomics, we would do the same sort of thing. We could actually say, let's say we had this guy right here. What would you call that? Well, first off, you have to be able to recognize your polyatomics, and you have to know that that is a nitrate. You also have to know that the 3 came from the iron when we crossed, and so this is iron Roman numeral 3 nitrate. Y'all see that? Iron Roman numeral 3 nitrate. Now, common mistakes. All right, I love showing common mistakes because I don't want you to be this person. Okay, here's a common mistake. Let's say you're naming. Here's common mistake. Let's say you're naming, say, this guy right here. Okay. Common mistake. This is so common. You look at that and you go, yes, I need a Roman numeral. I need a numeral. And you're right, you do need a numeral, right? It's iron. It's one of those that has more than one charge. Here's a common mistake. They copy down the 2 and they go iron Roman numeral 2 sulfate. You see what I just did? I went straight down instead of crossing. That's not iron Roman numeral 2 sulfate. That's what? That's, I'm going to put it in green because it's right, and that would be iron Roman numeral what? 3 sulfate. Y'all see what I did? You see how I pulled down that 2? Common mistake. Here's another common mistake. Let's say we're going from the name. Let's say we got iron Roman numeral 3, let's say sulfide, and ide means the atom. That means it's just S. Okay, ide means S. 8 would be sulfate, that'd be SO4. Ide would be just S. It's all about the ending. See the 8? See the ide? So a common mistake here would be to, once again, to just pull it straight down. Do you see what I just did? See what I just did? I just pulled it straight down, and being that this is iron 3 plus and this is sulfide, which is 2 minus, and a common mistake is just to pull it straight down. See what I did? You got to cross the charges. The 3, let me do this in green, the 3 on the iron goes to the sulfur, and then the 2 on the sulfide goes to the iron. You got to cross the charges. They got to cross. Okay, y'all see that? You see what I'm doing about common mistakes? Common mistake would be just pulling them straight down. Keep in mind, the Roman numeral part means the charge on the iron. Okay, and since you have the charge, let's go pull up a new slide here to kind of illustrate what's going on here. Let's say you have iron Roman numeral 3. Let's do sulfate. Why not? Okay. Now here's the thing. We're going to go from the name to the formula. Okay. So there's a couple things that have to happen here. You can't just write the formula. You can't just jump straight to the formula. I mean, I can because I've been doing it for a while. But what you have to do is you have to take that first step. Step 1, you have to write down what it is. Okay? You have to write down what it is. Then step 2, now we can go ahead and cross those charges. Okay? And so the 3 is going to cross down onto that sulfate right here. See? And that 2 is going to cross down off the sulfate onto that iron. You see that? So that we have iron sulfate with parentheses with 3 of them. This part right here, part number 1, This part number 1 is often skipped. This step right here. It's often skipped. And we're going to go backwards as well when we start doing something called dissociations and such. We're going to go backwards. We're going to actually go back the other way where we go to the formula to the ions, and that's also often skipped. And what I mean by skipped is you have to write down what the charges are. You have to know the charges to be able to cross them. Once you cross them, then you can get the appropriate formula. Everybody see that? You see how that works? Okay. I'm showing you these things, and a lot of stuff in Chemistry 151 is going to be like this. There's more than one step, and if you skip a step, then bad things happen. If you skip steps, and this is a step. Step number 1, you really don't ever try to skip that step. Okay. All right. We are almost done here. Any questions on this polyatomics and multiple charges on ions? Anybody got any questions on that? Y'all see how that works with the Roman numerals? All you're doing is just saying what's the charge on the metal. That's all you're saying. Okay. So let's see, where are we at here? Now we're supposed to finish up this chapter on Friday. And how much do we have left to go here? Okay, well, I think this is a pretty good stopping point, and we will finish up chapter 2 on Friday. Okay, we're going to finish up chapter 2 on Friday. And so, all right, hold on. I just did something weird. All right, we're going to finish up on Friday, everybody, okay? Now, if you have any questions, just kind of hang around and unmute yourself and ask questions. So I'm going to go ahead and turn off the recording, and we're going to stop